If you're a Swift developer, you have absolutely hit this wall before. You're designing this perfect protocol, everything's clean, and then you think, you know what? I just need to store one little piece of data right here. And you can't. It's that one nagging question that probably sends more developers to Stack Overflow than anything else. So let's just get to the bottom of this once and for all. Let's just put the question right out there. Can you, or can you not, stick a stored property inside a Swift protocol? It seems like it should be a simple question, right? And there you have it. The simple, kind of blunt, and often really frustrating answer is a hard no. You just can't do it, end of story. Or is it the end of the story? See, while the direct answer is no, the real answer, the one that really unlocks the power of Swift, is so much more interesting. The why behind this rule and the clever ways we can work around it are actually central to how you write great Swift code. To really get this, we need a good analogy. So let's think about the difference between a blueprint for a house and the actual physical house itself. They're related for sure, but they are fundamentally different things. A protocol, that's your blueprint. It's just a list of rules and requirements. It says, hey, any building that follows this plan must have a front door, and it must have at least one window. But the blueprint itself is just paper. It doesn't have rooms or walls. It takes up no space. It allocates zero memory. And this is where it all clicks. The protocol is the blueprint. It just defines the rules. The struct or the class, that's the house. It's the real thing, with a concrete layout taking up actual memory. It's where you put your furniture, or in our case, where you hold the actual data. So protocols describe what to do, but the concrete types are the ones that hold the actual stuff. Okay, so if protocols can't store anything, how do we get the job done? Well, let's start with the most common, the most Swifty solution out there. The whole idea here is super simple. The protocol makes a demand, and it's up to the type that adopts it to figure out how to meet that demand. The protocol says, I need this property, and the struct or class says, no problem, I got this, I'll provide it. Just look at this classic example from SwiftUI. The identifiable protocol, all it does is require an ID property that you can read from. It doesn't say how to store it or where it comes from, just that it has to be there. So our user struct conforms to it by simply providing a concrete stored ID property. The protocol makes the demand, the struct provides the goods. It's a really clean separation of concerns. All right, let's look at another super common example of the same pattern, this time with a property you can both read from and write to. But the main idea, it's exactly the same. The type is always responsible for its own data. So in this case, our nameable protocol requires a name property with both a getter and a setter. That's what the get-set part means. And our person struct says, easy. It just declares a regular var for name. Once again, all the responsibility for actually storing that data is completely inside the person struct. Okay, but what happens when you're in a really tricky spot? What if you need to add a property to a class that you didn't even write? Well, for that, we have to pull out an advanced technique, a real pro move that taps into the Objective-C runtime. Now, this is a very specialized tool. It's not something you're going to reach for every day. You pull this out when you need to do something kind of wild, like adding a new stored property to a system class you don't own, like UView, maybe through an extension. It's an incredibly powerful way to retrofit existing classes with new state. Yeah, the code might look a little intimidating at first, but it really just boils down to a 3-step process. First, you set up a unique key to identify your new property. Second, in your getter, you use a special Objective-C function to go find that value using your key. And third, in the setter, you use another function to attach or associate the new value to the object. You're basically bolting on a new piece of storage where there was none before. So here's the magic. By using this technique, a class can conform to a protocol and get what acts exactly like a stored property, and it's all defined inside a protocol extension. It's like you're performing surgery on a class to add a brand new feature, all without ever touching its original source code. Pretty cool, right? So let's do a quick recap with this handy little cheat sheet. For like 99% of your use cases, you're just going to use computed property requirements or have the types store the data itself. That's clean, it's safe, it's pure Swift. Associated objects, that's your power tool. It's the specialized wrench you pull out when you need to modify existing classes that you don't actually own. Okay, so we've seen the rule and we've seen the workarounds, but why? Why does Swift do this? Why go through all this trouble instead of just, letting us put stored properties in protocols? Let's bring it all home. We've established that protocols are just blueprints. They can't store data. For most cases, the conforming types will handle the storage. And we even have a power tool, associated objects, for those really special cases. See, this isn't an accident or an oversight. It's a very, very intentional design choice. And here's the real punchline. By not letting protocols have stored properties, Swift guarantees that they stay as nothing more than a list of requirements. They are incredibly lightweight, super flexible, and this clean separation of concerns, the definition versus the implementation, that is the absolute heart of protocol-oriented programming. It's what makes Swift so powerful. So you see, understanding this isn't just some academic trivia. It is fundamental to writing clean, scalable, and truly Swifty code. It unlocks so much flexibility and power. So the real question is, now that you know the rule, the reason behind it, and all the workarounds, how are you going to use these patterns to build your next amazing app?